My name is Thad McCoy. I'm an application engineer with Mechatronic Solutions. Been with Mechatronic Solutions for roughly 2 years and been in automation for about 25 years. In order to talk about the autonomous mobile robots, what we want to do first here is get an opportunity to speak on who is Omron. Omron is a company that was founded in 1933. They've been around a very long time, nearly $10 billion in sales. They're a global company, and they are about 44% of their automation is, I'm sorry, their business is in automation, industrial automation. So for those that are familiar with Omron, they are a kind of a global leader, I guess I would say, in the automation arena. Going to be seeing those Siemens, the Rockwells. They're another company very similar to those that are focused in the automation arena. And they are not exclusive to particular regions. They are truly a global company and have a very strong presence globally. So in events or situations where there needs to be shared information from one region to another, that is very possible, and it makes application sharing very easy for customers as well. All right, so let's talk briefly about some of the advantages to using Omron technologies. So we're not going to spend much time on this, but it's important to get an infrastructure and understanding as to how Omron develops their technologies to play well together. So with respect to this, Omron releases technologies that are intelligent enough to be easily integrated and be interactive and make it easy for operators and technicians, engineers to troubleshoot and utilize the equipment. So it's important to kind of get that generalized foundation and understanding that when Omron comes up with technologies, it's not meant to be just a standalone technology that isn't meant to play well with other things. So Omron's very focused on this kind of concept, and it does relate specifically to the AMRs we'll talk about here as well. So let's get into the autonomous mobile robots and Omron's offering of these. So to do this, what we first want to do is kind of build that foundation again, kind of talk about what is an AMR and how does it truly work in its environment. So to speak to this, what we're going to do is kind of look at three different kind of scenarios and kind of build the story as to how each of these kinds of work. So the easiest way to think of this is the manual logistics, thinking about people that are kind of just walking down the street, similar to what you would have for fork trucks or people with manual fork carts that would be walking through aisles in a factory. There is no coordination at all. It's kind of a free-for-all, and if somebody happens to walk around a corner, you're kind of at your own mercy of trying to make sure you don't run into anything. The next approach is the traditional automation approach. This is kind of more of an analogy to AGVs or to conveyors. And what we mean by that is think of like a bus route, right? So you're going to have very specific locations for people to be picked up and dropped off. It's going to follow a very predefined route to get to where it needs to go. It can't deviate. It's fixed on that route and a very tight time schedule. Whereas when we're looking at the newer technologies with what Omron utilizes with autonomous mobile robots, think of this like a fleet of taxis where they're all being coordinated to go out to pick up specific individuals. They're going out to do coordination. And if there are any issues, traffic jam, an accident, there are means for them to deviate their paths and go a different route to get to a destination. So this is kind of showing this in a better view, I guess, the traditional AGV, automated guided vehicles versus the autonomous mobile robots. So taking a look at the image on the right here, you have the more traditional AGV that would be following either like a set of beacons, maybe magnets on the floor, a tape, and then it has to follow that path in a very defined way, almost like a conveyor. It's very fixed. And if anything happens to get in its way, there's nothing it can do. It's stopped. It's until that obstruction is cleared. There's nothing that robot can do. When we're looking at the more modern AMRs, what you're doing is teaching them the environment, and then what it can do is identify the environment. If there's any changes, it can deviate its path, find a different route, and still get to its destination.
Have you ever considered how much time employees waste just walking around? It's not unusual in a warehouse or manufacturing facility for some to spend half of their shift walking. Manual material handling can lead to fatigue or injury when a worker performs repetitive tasks. But there is an easy solution. Introducing Omron Mobile Robots, the world's smartest and most productive autonomous intelligent vehicles. No facility modifications are required, including laser beacons, floor magnets, or tapes. The navigation is based entirely on the natural features of the facility, and the robot can be set up within an hour. Omron Mobile Robots increase throughput, reduce machine dwell time, eliminate errors, improve material traceability, and allow employees to focus on tasks that require more complex human skills. They can even reduce configuration costs because the mobile robots can adjust instantly to new workflows. They're designed to work safely around people. Unlike other robots that can only follow a fixed path or aren't centrally coordinated, Omron mobile robots can detect obstacles without having to wait for a specific path to clear. They also work collaboratively in a fleet. A central fleet manager provides traffic control for vehicle routing and optimizes plant operations. Omron mobile robots are the most advanced autonomous intelligent vehicles. Their flexible design enables endless configurations. It's a safe, intelligent, and field-proven solution that's delivered new levels of productivity and efficiency in the most demanding 24/7 operations.
So hopefully the video kind of gives you a general idea as to the technology and how it's designed to work. What we do want to do now is kind of take a look at Omron's product portfolio, their offering of mobile robots. What you're going to find is that the core of their offering is going to be right here in the center, as well as what is coming here in the very near future. With this, Omron is very focused primarily on the robots themselves. There are some generalized options that you might be able to get with some accessories, but those are not as common. Think of these toppers and things similar to like a traditional robot that you'd have an end-of-arm tool. What you're going to find is that your common like vacuum cups and stuff for like an end-of-arm tool for a robot is going to handle a large percentage of applications, and that's exactly the concept behind why someone like a Roic would come up with a topper. It's going to be a very good fit for a large number of applications, and it needs to work well with others. So what we're looking at here is the offering of the robots themselves, as well as the one that is coming soon. And then what is at the top here is what's called a fleet manager. We'll briefly talk about that here very soon as well. All right, so this is going to walk through the concept of how these get set up and configured. What you're doing first is you're plugging in a joystick. You're going to drive the robot through the environment. And as you're doing that, the onboard laser scanners and LiDAR is going to detect all of the environment that you're driving this past. And as you're doing this, it's going to store that information locally on the robot, and then it's going to report back what it sees. And that's what you're seeing in the center mapping image. And then lastly, what you're going to do is once you have that mapped infrastructure, then you're going to define where you want the robot to travel to. They're called goals, and then it's going to give you the ability to set up what are called routes or tasks to define how you want to have those operate, what kind of routes you want to take, what kind of number of sequences you're going to go through, those kinds of elements. All right. The next thing we're going to look at is commonly implemented approaches to this is if you're going to be going down a particular straight path, you want the robots to typically travel at a higher rate of speed. But in certain instances, you need it to travel at a slower rate of speed. So what this is showing is that you can adjust the sensing distance of the onboard safety scanner such that it has time for the robot to react and stop in time before it causes a contact with an individual. So as a robot is driving along, you can set that sensing distance so it's a safe utilization of the robot alongside people. The topic is what's called CAPS. That's an abbreviation for what's called Conveyor Accuracy Positioning System. And what CAPS does is it identifies how to interact with either an infrastructure of a conveyor, or more recently here with legs to like a cart. So it makes it easy for the robot to drive into and pick up a cart for pickups and drop-offs. And we'll actually see that in the next presentation here. All right. Now let's talk about the Omron Fleet Manager. The Fleet Manager is going to be, I guess, to make it simple, it's the traffic cop that's controlling more than one of the robots. So let's take a look at some of what it can do. So the Fleet Manager itself it looks like a blade server essentially. And what you're having the ability to do with this Fleet Manager is manage jobs. And what I mean by that is notice this robot right now was assigned to job 1. It's picking up that particular object. However, there are additional jobs that are in the queue that need to be handled. So the fleet manager recognizes that this robot is now tied to this job. It's busy doing something. So the fleet manager is able to recognize that and assign another robot to pick up the other jobs that are waiting. So rather than waiting for this single robot to complete its job and come back and then pick up the next job, it can manage the other robots. When we're looking at a scenario where it's interacting with the same drop-off location, you can put them into a queue, so you can make sure that they're waiting in line. It's no different than waiting in line at Disneyland to go on your next ride. It's dropping off the load, and it's getting in line to do so. One of the biggest thing then is the traffic control. So these things are going to be interacting with one another in the same environment. They're going to recognize the paths of travel that they're going to be going, and they can work very seamlessly together in that environment to make sure that there's not going to be any stoppages and such like that as they're driving past one another. Some of the other added elements, I'd mentioned that the maps are stored locally on the robots. If there are any edits to be made to the map itself or any of the routes or any of the goals, that can be sent to the fleet manager, and it can be pushed down to all of the fleet robots. So all of that would be handled in one fair swoop. The charge management, so if you have robots that are perhaps busy doing something, although it's reaching a lower battery level. What you can do is say, okay, well, I want to make sure that those robots that are reaching the lower battery levels are going to be prioritized for charging soon. So complete your task and go back and do a charging. And that's kind of what we're showing in this scenario. The last of which is the skill administration. So specific robots assigned to specific tasks. In this case, they have specific tools on top. So when you're assigning a specific task or going to a specific goal, only assign those robots that are basically designed for that purpose. Don't assign other robots that can't work with that particular that task. To talk about some of the toppers, as we mentioned before, similar to the traditional robots, you would have a lot of different potential options, like the traditional robots having the end-of-arm tools. Like I say, it's very common to have a common approach for a large number of applications. However, there are going to be instances where you need to have something more customized, and this is showing some of those examples. Another approach that can be taken is a combination of two different collaborative robot technologies, being a mobile robot as well as a collaborative. So the mobile robot and the collaborative robot working together to accomplish a task. This makes it a situation where the combined technology is safe to work around humans and then accomplish those tasks working together. The next topic, last topic here, is on the mobile planner. The mobile planner is the tablet edition is a means to see what the robot is doing on a remote tablet, so you can actually monitor what is going on. For those people that are coming to the open house perhaps next week, you'll get an opportunity to physically see this in action as well. So just understand that this gives a means to kind of get a snapshot on what the robot is currently doing and how it operates within its environment, if it's got any problems, troubleshooting, things of that nature.